Hey everyone, in this video we're going to predict the periodic trends for first ionization energy, electronegativity, and atomic radius. Now let's first remember what first ionization energy means. First ionization energy is the amount of energy necessary to remove the outermost electron. Electronegativity means the affinity an atom has for wanting to acquire new electrons. So therefore, if it has a high electronegativity, not only does it want to keep its own, but it wants to steal others. Now both of these are related to the octet rule, where the outermost electron shell wants to be stable. Now this information can be found on our reference tables. Table S, let me zoom in a little bit here. And on table S we have not only our atomic numbers right here, but the symbols for the elements that go with it, the names. We have the value for the first ionization energy, the values for the electronegativity. We even have here melting point, boiling point, density, and atomic radius. So we are going to go ahead and use these values with the periodic table, place the values into the periodic table so you could build the trends yourself. So there is no need for memorization. So here's our periodic table of elements. It has chock full of great deal of information there, but it does not give you the first ionization energy, electronegativity, or otherwise. So what I am going to do is have you focus on a few of the elements over here: oxygen, fluorine, and chlorine. Let me zoom in on those. And superimpose on top of these here, oxygen, fluorine, and chlorine. Superimpose onto this area the values for first ionization energy, electronegativity, even the atomic radius, so that we could see the trends. And what you will see here represents the trends that are experienced all over the periodic table. So let's do that. All right, again, we're going to focus on oxygen, fluorine, and chlorine. Let's zoom in on these values here of first ionization energy for oxygen. For oxygen, it shows first ionization energy for oxygen is 1,314. Fluorine is 1,681. And chlorine down here is 1,251. Let's go ahead and put those values in so we could see if we are in fact truly building the trend. Okay, so again, oxygen was 1,314. Now, I don't have room for the units, but the units is kilojoules. That's 1,000 joules per every mole. A mole we will discuss later on in chemistry. Okay, so fluorine was 1,681, and chlorine was 1,251. Get out of the way. 1,251. So as you can see, the trend is, as you move to the right across the period, the ionization energy increases. And as you move up the group, the ionization energy increases. All right, so now let's explore the same thing when it comes to electronegativities for oxygen, fluorine, and chlorine. For oxygen, it is 3.4. Let's put that in. 3.4. For fluorine, it is 4.0. And for chlorine, that's down here at atomic number 17, that's 3.2. So 3, grab the pen, 3.2. So again, thinking of it as you move to the right across a period, the electronegativity goes up. As you go up the group, the electronegativity goes up. All right, now let's explore the atomic radius. Atomic radius for oxygen. There's oxygen, atomic radius is 64. Units are in picometers. That's really small. Okay, oxygen, fluorine is 60. And chlorine is, where's my chlorine? Atomic number 17. It is 100. So, get this out of the way. 100. Now that says that as you move to the right, grab a different color, as you move to the right across the period, the radius of an atom decreases. Now the reason for that is simple. Even though you're gaining more electrons, you would think that it goes further apart. So think of it as here is a nucleus, and we're adding more electrons as we move to the right. But in fact, well, that is true, but you're also adding more protons, and because of that, even though you're adding more electrons to the same shell, the pull, the positive charge, has a greater pull on these negative electrons. So therefore, it pulls those electrons in tighter, even though you have more of them. Now, as you go up the group, the radius gets smaller, and that is simply because as you go up the group, you have less energy levels being filled with electrons. So therefore, of course, it is smaller. Now, let's see if in fact we built those trends. We'll take a look at a picture on the next slide that is very popular on Google Images to see if in fact by just exploring these three elements, we now do not have to memorize the trends. So now let's see if in fact we were correct. We have going across the top, we have ionization energy. It's actually the first ionization energy, and as you move to the right, it is increasing. That's true. As you move up a group, it is increasing. Absolutely true. For electron affinity here, now that actually means the electronegativity. As you move to the right across the period, it goes up. We found that to be true. And as you move up the group, we found that also to be true. Now, as far as the radius goes, we did also find that as we move to the left, the radius increased, because the converse is actually what we found. We found that as you move to the right, it decreased. So we do know that as you move to the left, the atomic radius increases. And we also found that as you move down the group, because you're adding more energy levels, therefore adding more electrons on a higher level, a level further away from the nucleus, that the atomic radius increases. So, in fact, we did find this to be true. We found all of these. You do not have to memorize them. All you need is your reference table, a periodic table, and inspect oxygen, fluorine, and chlorine. Put in the values and you own it. No memorization necessary.